Hello everyone, in this video I am going to solve different questions of exercise 9.2 of NCERT, chapter sequences and series. Let's see the first question. It is given in an AP if pth term is 1 by q. So I will be writing it mathematically that pth term is 1 by q and qth term is 1 by p. Prove that means I need to prove that the sum of PQ, first PQ term is equal to half of PQ plus 1. So these are the given things in the questions. Let's see what we can do. Here I know nth term can be written as a plus n minus 1 into d. In place of n, here it is given p, so I will be writing it as a plus p minus 1 into d. And here I will be writing it as a plus q minus 1 into d. So this is my equation 1 and this is my equation 2. Now children, whatever is given to you, you have to solve that only. So I am given with now equation 1 and then I am given with equation 2. I can solve these equations 1 and 2 to get the value of a and d. After getting the value of a and d, I will be putting it in the formula for sum of PQ term. Let's quickly find out the values of a and d from equation 1 and 2. So I have calculated the value of d and a by elimination method. Here this is my equation 1, equation 2. I have cancelled and solved it. I got the value of d. I have substituted this value in equation 1 and calculated the value of a. Now our question is to prove sum of first PQ term is equal to this. So I know that sum of PQ terms can be written as n by 2. Here n is PQs, that's why I have written PQ. 2a. What is your a? This is 1 by PQ plus n. What is your n? PQ minus 1 into d. And what is your d? 1 by PQ. I have simply put in the formula n by 2, 2a plus n minus 1 into d. I have just substituted the value. Let's solve it further. This is PQ by 2. I can take PQ common. So here I have taken PQ common. I am left with 2 plus PQ minus 1. So PQ and PQ gone here. This is 1 by 2. 2 minus 1 is just 1. So 1 plus PQ, which is my required answer. Hence proved. Have a look. Let's see this question. Find the sum to n terms of the AP whose kth term is given as 5k plus 1. Now children, you have read this type of question in class 10 that whenever your term is given in nth form or kth form, then by putting n or k equal to 1, 2, 3, 4, you have to first of all frame the sequence. So let's frame the sequence. So if I take, this is your term 5, this is your kth term given to you. So let's frame the sequence first by putting k equal to 1, 2 until n. So if I take k equal to 1, then I get it as a1 equal to 5 into 1 plus 1, which is equal to 6. If I put k equal to 2, then I get my second term, which is 5 into 2 plus 1, which is 11. Similarly, I can get my nth term as an equal to 5n plus 1. Right? Now I need to find out the sum of n terms. So I know sum of n term is given by 2a plus n minus 1 into d. So I will be requiring here a, that means the first term. So I got my first term here, but then I will be needing my d also. So let's find out d first. So d can be calculated by writing a2 minus a1. So your a2 is 11 and your a1 is 6. That means your d is equal to 5. Put a and d value over here. So I need to find out sum of n terms. So my answer will be in n terms only. So this is n by 2, 2a is 6 plus n is n only and d is your 5. So finally I am getting it as n by 2, 12 plus n minus 1, or I can simply multiply this 5, so I will be getting it as 5n minus 5. On simplification, I will be getting as 12 minus 5 is 7 plus 5n. So this is the sum of your n terms of the given sequence. See this question, children. It is given here the sums of n terms of two APs, two different APs are given to you, are in the ratio this. That means this is, say, sum of the first series, which is given by n by 2, 2a plus n minus 1 into d. Now children, when you are taking, say, another AP, that means arithmetic progression, two different arithmetic progressions are given to you. So you will be writing it as, since I am taking sum of n terms only, so I will be writing it as n by 2. Since two APs are different, so I will be writing it as 2 capital A plus n minus 1 into capital D. See children, if you are using the same AP, then only you can use the first term and the first term and the common difference as same. Otherwise, the denotation should be different. Are in the ratio. Ratio is up, that means this by this is equal to 5n plus 4 by 9n plus 6. Now children, on solving these two, n by 2 gone with n by 2, so I am left with now 2a plus n minus 1 into d whole upon 2a plus n minus 1 into capital D equal to 5n plus 4 by 9n plus 6. Now I cannot solve it further, so let it be here only, and let's see what it is asked in the question. Find the ratio of their 18th term. That means I need to calculate my 18th term ratio of two different APs. I know that 18th term, whose first term is A, can be written as A plus 18 minus 1, that means 17D, and this again can be written as, if I am taking it as A 18th, then let it be A dash, or I have taken it as capital A, so I will be taking it as A plus 17D, because n is same for both the APs, so 17 capital D. Now children, you can see here, we can compare these two because we cannot solve them further. So let's find out by comparing that how we can equate one to another by replacing what term. So here it is 2a n minus 1 into d. Here it is a plus 17d. So if I want to make it 2a, so I'll be multiplying this complete term with 2 and this complete term with 2 also. So I can get it here as 2a plus 34d whole upon 2a plus 34d. Now children, you see that I have got ratio of 18th term as this, and this is given as sum. Now you see this is 2a, this is 2a. In place of n minus 1, it is given as 34. That means this n minus 1 is equal to 34. Here also this is 2a, this is 2a, n minus 1 is 34. That means your n equal to 34 plus 1, which is equal to 35. So here your n takes the value 35. So this is the value of n, and if I want to find out the ratio, since now these two are equal, this one and this one, these two are equal, so after multiplying I can say this is equal to this only, 5n plus 4 by 9n plus 6. Now if I am replacing n with 35, so I will replace n here also with 35. So here what I am doing is, I will be writing the ratio of a 18th term of two different AP as 5 into n is 35 plus 4 by 9 into 35 plus 6. And on calculation, I will be getting it as, So after solving, I will be getting this ratio of the 18th term as 179 by 321. See this question, children. It is given sum of the first pth, qth and rth term. That means sum of the pth term is given to you as A, sum of the qth term is given to you as B, and sum of rth term is given to you as C. You need to prove that this equal to 0. Now whatever is given to you, you have to start with that. So sum of pth term can be written as n by 2. Since n is p here, so I am writing p by 2, 2a. I will not be using small a because small a is already given to you. So to avoid mixing of these two, I am writing it as capital A. 2a plus n. n is p minus 1 into d. Here again I can write it as q by 2, 2a plus q minus 1 into d. And here sum of rth term can be written as r by 2, 2a plus r minus 1 into d. So these are the three equations which I have got from the given. Now you see, children, here it is given q minus r, or I can simply say this is given as a by p. So this p, if taken down, then I can get the value of a by p. So a by p equals half of 2a plus p minus 1 into d. I have just taken this p down and written rest of the things as it is. Similarly, I am writing it as b by q equal to half 2a plus q minus 1 into d. And this is c by r equal to half 2a plus r minus 1 into d. Now I have got these three new equations. Now children, I can see here a by p is multiplied with q minus r. So I can multiply this complete equation with q minus r. Here it is r minus p. So I can multiply this equation with r minus p. And here it is multiplied with p minus q. Now children, this q minus r multiplication means you have to multiply q minus r with this term also, with this term also, and with this term also. Similarly, this will be multiplied with this will be multiplied with this, and this will be multiplied by this. Now here it is in between plus sign. So after multiplication, you add your left hand side and your right hand side. So I can write my left hand side as a by p q minus r plus b by q r minus p. I am just multiplying these terms and then adding r minus p plus c by r p minus q. And this side I will be getting it as half 2a q minus r plus p minus 1 q minus r d. So this is the first term, plus again half 2a, I am multiplying this with this, so r minus p plus q minus 1 into r minus p into d. Again the last term, half 2a p minus q plus r minus 1 into p minus q d. So this is my left hand side and this is my right hand side. So if you solve this, that means your right hand side, then all the term will get cancelled with each other, and here it will become 0 only, which was the required proof. So hence you will be solving it. See this question, children. Here it is giving the ratio of the sums of mth and nth term of an AP. So sum of mth and nth term of an AP is given to me as m square by n square. So let's expand this sum of mth term, which is m by 2, 2a plus m minus 1 into d. This is, again I have used the same formula, n by 2, 2a plus n minus 1 into d. So here again this is n by 2, 2a plus n minus 1 into d. Since for same AP we are calculating its mth and nth term, that's why I have used same first term and same common difference. Here this 2 is gone with this 2, this m is gone with 1m, n is gone with this 1m. So finally I am getting it as m by n equal to 2a plus m minus 1 into d whole upon 2a plus n minus 1 into d. Now children, I cannot solve it further, so I am leaving it here. Now you see what we need to find out. Show that the ratio of the mth and nth term, ratio of mth and nth term is given by 2m minus 1 upon 2n minus 1. This we need to prove. So I can write mth and nth term as a plus m minus 1 into d and a plus n minus 1 into d. Children, let's compare these two things. Here it is 2a and here it is a only. So let's multiply this with 2. So if I multiply this complete with 2 and then again I multiply this with 2, so I'll be getting it as twice of a plus twice of m minus 2 into d, and here I'll be getting it as twice of a plus twice of n minus 2 into d. I have multiplied 2 inside. Now children, if we compare these two, then I can see this is 2a over here, this is also 2a. This is m minus 1, but here it is 2m minus 2. Children, remember in our previous question, we have replaced n with some value, but here since m minus 1 and n minus 1 are different, that means on both the positions we have different things. So we cannot just replace m with a single value, m and n with a single value. We have to find out values for m and n. Let's see how we can do it. So 2a is same for it. Now if I replace this m with m minus 1, or I can say 2m minus 1, then I will be able to get this. This is just a replacement. So if I replace this m with 2m minus 1, replace m equal to 2m minus 1 and n equal to 2n minus 1, then what will be I getting? I will be getting it as 2a plus 2m minus 1, and this is minus 1 already here. I have written m as 2m minus 1 and this minus 1 as it is, and this is d. Again 2a plus, this is 2n minus 1, I am replacing n with 2n minus 1. Again this is minus 1 into d. So I am getting it as 2a plus 2m minus 2 into d upon 2a plus 2n minus 2 into d. And since I have replaced m with 2m minus 1, so I will be replacing this also, and I will be replacing n also with 2n minus 1. So here this complete value gives me a ratio of mth and nth term. So ratio of mth and nth term is equal to this. Hence proved. This thing I wanted to prove. So I have got am by an is equal to 2m by 2n minus 1. Hence proved. Let's see this question, children. It is given if this is the arithmetic mean between a and b. So say a and b, and this is the arithmetic mean. This is your arithmetic mean. Okay. Between a and b, this is the arithmetic mean. So we know that arithmetic mean can be written as half of sum of these two. So this is your arithmetic mean. Okay, arithmetic mean is this. Now I'll just simplify it. Cross multiply, this will be 2a raised to power n plus 2b raised to power n equals a into a raised to power n minus 1 plus a into b raised to power n minus 1 plus b into a raised to power n minus 1 plus b into b raised to power n minus 1. So let's simplify it. This will be 2a raised to power n plus 2b raised to power n. This is, bases are same, they are in product, so parts will be added. So I'll just get it as a raised to power n plus a into b raised to power n minus 1 plus b into a raised to power n minus 1. Bases are same and they are in product, so powers will be added. So I will be getting it as b raised to power n. Take this a raised to power n this side, so 2 into a raised to power n minus a raised to power n will become just a raised to power n. This b raised to power n when come to this side, again it will become b raised to power n equal to, now I am left with a into b raised to power n minus 1 plus b into a raised to power n minus 1. Here the value, this is in power, b raised to power, so I will bring this to this side, so it will be a into b n minus 1 minus b raised to power n, and I will bring this term to this side, so this will be a raised to power n minus b into a raised to power n minus 1. Now out of these two I can take n minus 1 common because this is the lower power. So I have taken this out and here I will be left with just a. I have taken n minus 1 out, so I have just got a minus b. Here again taking common as b raised to power n minus 1, I will be getting it as a minus b. So a minus b and a minus b gone. I am doing it here. So it is a raised to power n minus 1. I can bring down here b raised to power n minus 1 and here it is equal to 1. Now if I want to calculate the value of n, then I can replace this 1 with, say, I can compare the powers only when this is also in a by b form. So this can be written as a raised to power 0, or simply this can be written as a by b raised to power n minus 1 equal to a by b raised to power 0. Now bases are same, equal to sign is there, so I can compare the powers. So this is n minus 1 equal to 0, which gives me n equal to 1. Isn't that easy?